Greetings. Welcome to Machine vs Mathematics channel. Here we have another interesting question from jet transform asked in GATE ECE 2016 set 3 for 1 mark, just for 1 mark. You see discrete time signal x of n equal to delta n minus 3 plus 2 delta n minus 5 has jet transform x jet. Now if y of z is equal to x of minus z is the jet transform of another signal y of n. So therefore we have a couple of signals x of n and y of n, and whose jet transform y of z is given like this, and we can find x of z of x of n as well. Now then he is asking, we have 4 options here. Which one out of 4 will fit this question? Let's check it out. So you see, this is not a big deal. Just go with your usual skills. Definitely we can win this question. You see, first of all, let us take our sequence. I mean, our signal x of n is delta n minus 3 plus twice impulse, shifted impulse. So linearly shifted impulse functions we have as x of n. So now what can be done? Yes, so I can find its x of z directly, but thing is that he is saying that y of z is equal to x of minus z. Okay, so first of all we will take care of this x of minus z. How do we get x of minus z? See, there is x of minus z means something, this quantity got scaled. Okay, that means we have to go for scaling in the z domain property. You have one of the properties, that is scaling in the z domain. So how do we get scaling in the z domain? For example, see, whenever you have this negative z, think of this is something like minus 1 into z or 1 by minus 1, something like that. So that quantity is scaled quantity to this x of minus z. That is, what I want to say is this: x of n z transform is x of z. Okay. Now if I multiply an exponent here, say I have n as exponent, a power n x of n, if I do this, now we will get x of a inverse z. Okay, now you see this is what scaling in the z domain. So this z now became a inverse or 1 by a multiplied by z. So otherwise you could say x of z over a. Yeah, so this is how we get x of z by a when input is like this. Now what can we conclude from this? See, I have x of minus z, but in this case I have x of a inverse z or x of z by a. So that means if I assume a is equal to negative 1, see how simple? Let us say a is equal to negative 1. If a is equal to negative 1, so this time domain quantity, this is what a power n, right? So minus 1 power n x of n, minus 1 power n x of n z transform is x of what now? If I take any of the problem, say this is z by minus a, I mean z by minus 1, a is equal to minus 1, so this becomes x of minus z. So now we have come to this conclusion. You see, x of minus z, its inverse is minus 1 power n x of n. So this point we want now. Then only we can establish link between x of n and y of n properly. Okay, so let me go for next page. There is no big deal in solving this. This is a simple one. But if you want to know, if you want to know this, for example, you see, what do we have here? A power n x of n is x of a inverse z. If you want to know that scaling in the Z domain property. Now say what we have. According to definition, Z transformation of a discrete time sequence is say x of z. That is, say you have n is equal to minus infinite to plus infinite. So you have this basic definition, right? So this is well known to us. Now what are we going to find? We are going to find Z transformation of a power n x of n. So in place of this x of n, as it is Z transformation of x of n, we have x of n here. Now it is Z transformation of a power n x of n, so take a power n x of n. Okay, now as it is, say this is our say it is like kernel Z power minus n. Now for the same limits, n is running from minus to plus infinity. Now just this is our reference definition, right? So you just modify this in this form, then that's the answer, you see. So how do you do this? N equal to minus infinite to plus infinite. Let me modify this as follows: x of n. Now this quantity I'll take it here. Okay, so now this becomes what? If I make a inverse z whole power, this is say n. Okay, so this is a inverse z. Let me take this is a inverse whole power minus n, because minus 1 multiplied by minus n is positive n. So a power positive n and z power minus n. So this got satisfied. Now this is say 1. Now designate this one by 2. Now you see, here we have same limits, here we have same limits, and here we have x of n. Again we have x of n. Yes or not? Now this one you observe carefully. See, in this brackets you have z. So x of n, z power minus n, whatever we have in this bracket, that is what this x of z. Yeah, that is what we're taking it here, right? Now same, n equal to minus infinite to plus infinity, same, x of n same. Now in place of z we have a inverse z. So therefore this will be x of a inverse z. That's it. So this is how we can prove scaling in the Z domain property. So okay, so therefore this is okay, this is fine. All right, so anyways, inverse of x of minus z, we have minus 1 power n x of n. So we will take it as granted. So now minus 1 power n x of n. Let me take another page. So what we get is this. So what we have is minus 1 power n x of n. This is what Z transformation of this is, x of minus z. This is what we obtained by letting a is equal to minus 1 in our compact form. All right, so now but what is your x of n? But given to us x of n is equal to delta of n minus 3 plus twice delta of n minus 5, right? So this is what given to us, you see. X of n is this in the question, delta n minus 3 plus twice delta n minus 5. Okay, now also he gave us y of z equal to x of minus z. So let me revisit that relation like this. Say also you have you see, so also you have given y of z equal to x of minus z. Now what is the question? Question is, if this is so, then what must be the correct option? So we have to establish a link between y of n and x of n. You have in the options all in y of n, x of n format. So therefore it's time to take its inverse. Okay, if I take its inverse, on the left hand side we get y of n. So I am taking inverse z transform, we get y of n. Now what is inverse of x of minus z? This is what we have. So now that means y of n is equal to minus 1 power n x of n. Clear? So this must be crystal clear for you. So y of n is equal to minus 1 power n x of n. But what is our x of n here? Our x of n is this. So y of n equal to minus 1 power n multiplied by x of n. Let me take open bracket here. So x of n is delta n minus 3 plus twice delta n minus 5. Now we can use one of the finest properties of this impulse function. You see what you have, minus 1 power n delta n minus 3, okay, plus what you have again, minus 1 power n multiplied by twice delta n minus 5. So now what we get, okay, so how do you do this? You have this property of you have this beautiful property. So now what you do is this. Now let us say you have x of n multiplied by, say, delta of n minus k. Now this becomes what? So this multiplication is like this, x of k multiplied by delta n minus k. Alright, so we have this beautiful property of impulse function. So x of n multiplied by delta of n minus k means if x of k is defined, then we have x of k multiplied by delta of n minus k. So this is a well-known fact for us. So accepting this as it is, so let us apply this stuff over this. So we get this is acting like x of n, okay. So x of n multiplied by delta of n minus k. So now we get x of k. So replace n by k. So x of k. So we are replacing this n by 3 multiplied by, see, x of k, again same delta n minus k. So 3 plus again minus 1 power, this fellow will appear here now. So minus 1 power 5 multiplied by, again take same stuff to this one. So this is minus and again minus, right? So therefore we get like this. So this is minus of delta n minus 3 plus twice delta n minus 5. So we took this minus as common, this negativity we took it as common. So we have like this, and in the left hand side what do you have? So this fellow is waiting to appear here now. So all his waiting have come to reality. So y of n is this. Now this bracket content is what? This bracket content is this x of n. Alright, so this stuff is x of n. So now what is the correct option? So what did we get now? So y of n is, I have minus, so minus x of n. So this is the correct option, or this is the correct answer. So y of n is minus x of n. So option number C is correct. Right? So there is no big deal in solving this. Just we have solve, one step after the other in some great detail. Otherwise we don't require to take this time. So for explanation point of view I took this time. Otherwise we should not take more than 30 to 40 seconds to solve this question. There is no big deal, right? So the only thing what you have to think is this one, x of minus z. So this is not usual, right? The usual stuff is x of z, y of z kind of things. They are usual stuff. So whenever you have like x of minus z or x of z inverse kind of stuff, immediately you have to go to z transform properties, because in GATE examination especially, they obviously ask questions from properties. How smartly are we applying properties over solving questions? That definitely they will check. They don't check your lengthy mathematical skills in competitive examinations. In competitive examinations, to tackle a particular question, how smartly are we trying to utilize our available properties or facilities? We should know how to utilize the facilities. Yeah, the beautiful facilities in jet transform or any other transform is their properties. That is the strength of that particular property, I mean particular transformation technique. So therefore just go through all your properties and try to apply them smartly over questions. So you should know which property to be applied in no time. So for that you require great practice. Otherwise anybody can do. So this is not a very tough examination. The only thing is, you knuckle down with your fundamentals, you go over with your basics. So definitely you can solve almost all questions asked in gate examination. So we will try to make things very simple in this channel. So we will try to understand things one after the other in great detail. So we need not worry, or we need not hurry up in getting things done. Okay, so that's it for today. You can share your thoughts in the comment section below. So for now, it's time to say bye. Thank you.